Okay, so this is the video notes for Honors Math 3, Unit 10, Objective 4, and this is mostly solving equations and a graphing review for your polar. So you are going to need a calculator and make sure that you are in reading mode. So either graphing or regular calculator, doesn't matter. Just make sure you are in radian modes. Okay, so this is definitely going to be a very challenging lesson. If you do not take the time to press pause and attempt the problems first after I show you one of them. If all you're going to do is kind of watch through it, it's not going to really make sense because you're not giving yourself time to process what we're going over. So again, it is really important for this lesson to take the time to press pause and attempt a problem prior to me working it out, okay? So I'll always do the first one, of course, just so you can get an idea of what's happening, and then press pause, try the second one, check to see how you did, press pause, try the third one, check to see how you did, and so on and so forth. And if at any point you're struggling, then that would be the time to go and take a look at the extra practice problems, maybe the homework help problems, maybe try to do the homework a little bit first. But definitely make sure that you are kind of chunking the information and learning as you go, because if you struggle with the first three, you're going to struggle with the rest of them. So do make sure that you do what you can to process, and pausing and attempting first is always a good start. Okay, so let's go ahead and take a look at question number 1. So this is a review off of our Unit 8. So if you don't remember it or you're really struggling with it, you can go back and maybe look at your Unit 8 notes and homework and kind of see how you did there, okay? All right, so the first thing we want to do is we want to solve for theta, and we're going to be in radians because of the 0 to 2 pi. So in order for us to do that, we're just going to isolate the trig function. So I want to get theta by itself. So I'm going to take the sine inverse of both sides. So this is not on my unit circle, so I can't look, oh, hey, where the heck is 1/3? So I do have to type it into my calculator, so I'm just going to do that off screen here. So I'm going to find the sine inverse of 1/3, and again, I'm making sure that I'm in radian modes. Okay. So then when I do that, I'm going to end up with 0.33 and then 98. And you can either round or truncate. It really doesn't matter which one you do. Okay. All right, so I am needing to find a second answer, right? So if I take a look at sine, I know that sine is a positive ratio, right? Because this is a positive ratio in quadrants 1 and 2, because sine is the y value. So what I found was theta prime, right? So theta prime, so that's what I just found there. And so that would give me the 0.3398, and so that's that first value in quadrant 1. Normally I would write theta prime, but since I know I have an answer in quadrant 1, I'm just going to go ahead and find my two answers. And then I need to find my second answer over here in quadrant 2, and I know that if I were to rotate over to this quadrantal, that would be pi. And so I need to find this rotated angle here, right? I need to find that rotated angle. So this gap here, right, this reference angle gap, so this guy here and this guy here, they have to be exactly the same. So if this is 0.3398, so does this one have to be, right? So those are both 0.3398. And so in order for me to find the value in quadrant 2, then I just have to say, okay, I didn't make it all the way to pi, right? I stopped before I got to pi. So that means my answer has to be smaller. So then I'm going to find pi, and then I'm going to subtract my reference angle of 3398, and then that's going to give me my quadrant 2 approximation. So then I'm just going to do pi minus 0.3398 in my calculator, and then I got 2.8017. Okay. So then my two values for where sine is positive between 0 and 2 pi is 0.3398 and then the 2.8017. So I went out to 4 values. You only need to go out to 3. So your answers could be the truncated version, so 339 and 2.801, or the rounded version, 0.340 2.802. So either would be acceptable. Okay. All right, so let's go ahead on to number 2. So again, this is where you should press pause, try number 2 first on your own and see how you fare. Or go back and rewatch 1 if you were still kind of confused on that one. Okay? All right, so again, I want to isolate theta, so I'm going to go ahead and do cosine inverse of both sides. And then again, making sure that I am in radian mode. Okay, so radian mode. So here, so normally we would write theta prime, but I know theta will just be one of my answers, so I'm just going to go ahead and just go straight into that. And so when I type that into my calculator, I get 2.4188. And so then now I need to find my other value. So I know that for cosine, it's the x value, so that's where cosine is negative, so I have a negative ratio here. So cosine will be negative when I head to the left. So I'm looking for these 2 values here. So one answer in quadrant 2, and then one answer in quadrant 3. And so I know this is pi. So this rotation to here is 2.4188, and then because of symmetry, this distance right here also has to be that same value, or that same value, right? So I know when we did this in class, we talked about 2 different ways to kind of find these 2 values. And so keep that in mind, right? There are definitely multiple ways to come up with the same answer. So I'm just going to do it one way though. So for quadrant 3, what I take a look at is I know that this distance here is 2.418, right? So does this distance. And so the way I want to look at it though, because what I'm really searching for is my rotated angle from 0. So I'm looking for this gap right here, right? I'm looking to see, well, what is that gap? Well, if I go all the way around a circle, that is 2 pi. And so the only piece I know about is a full rotation is 2 pi, and then I know the distance here to here is 2.4. So that means that if the whole thing has to be 2 pi, and this section is 2.4, then what's marked here in this green is going to be 2 pi minus, right? Because it's not a full rotation, I am short by that 2.4 value. So then I want to take 2 pi and subtract it by 2.4188, and so then that value, when I do that, is 3.864. Okay. So then my other value will be 3.864. Okay. So before we start number 3 together, you should be pressing pause and trying that one on your own and see how you do. Okay. All right, so again, the first thing I want to do is I want to do tangent inverse of both sides. And then I just type that into my calculator and get a value. And then I got negative 0.6747. Okay. So then now I have to take a look at where is tangent negative, right? So where is tangent negative? And so I know that tangent is negative when the slope is negative. So the 2 quadrants that I connect to get a negative slope, because tangent is y over x. So that would be in quadrant 2 and then also in quadrant 4. So the value that I found, this negative 0.6 number that I found, is not up here in quadrant 1, right? It's actually this guy right here. So this distance right here is that negative 0.67 value. But the problem is when I do my angle values, I have to do a positive rotation. So then I'm going to have to use my reference angle information and symmetry to figure out those numbers. So this is pi over here. So if this distance is 0.67, this distance is as well, right? So that distance is also negative 0.6747. Okay. So I have two quadrants I have to solve for. So I have quadrant 2, so let's start with that one. So from 0, I have to rotate into quadrant 2. So when I go from 0 into quadrant 2, I don't make it all the way to pi, right? I stop before I get to pi, and I stop by this amount, this 0.67 amount. So that means for quadrant 2, I'm going to do pi, and I'm stopping before it, so I'm going to subtract the 0.6747 value. And then you would just type that into your calculator. So make sure you're using your pi key, don't use 3.14. Make sure you're using your pi value to do that. And so when you type that in, you are going to end up with 2.466. So that's one value. And then I also have to find my quadrant 4. So for quadrant 4, again, I have to rotate from 0. So from 0 in a positive direction, so over into quadrant 4, so this one right there. So when I look at that, I don't make it all the way to 2 pi, right? So I stop before I get to 2 pi, and I stop 0.6747 away, right? So in order for me to find quadrant 4, then I'm going to do 2 pi. I stop before I get there, so it means it needs to be smaller, so I'm going to subtract. And so then I would just do 2 pi minus 0.6747, and again, you would just type that into your calculator. And so this time I got 5.608. Okay. So then my two values, so this cannot be one of my answers because my domain is only from 0 to 2 pi. So we always need to make sure we're knowing, what is that domain. So I can't use that negative answer because it's certainly not greater than 0. So then my theta approximations would just be these two right here. So 2.466 and 5.608. And those would be my two angles that I would be finding. Okay? All right. So if 1, 2, and 3 you were fine on, then you are going to be good to do the rest of the problems. But if you were struggling with 1, 2, and 3 at all, you should definitely take a look at some of those extra practice questions and try those until you can figure it out or reach out to your teacher. Okay? All right. So let's go ahead and move on. So for this one right here, so for 4 and 5, it'll be a lot like what we did up above, a lot like what we did in the last chapter, where we're going to be solving and watching out for those multiple angles. Okay, so for question number 4, so they ask us to solve for theta, where theta is between 0 and 2 pi. So just a reminder, this is an element of, right, that weird little symbol there. So theta is an element of the values from 0 to 2 pi, including 0 and including 2 pi. So including 0 and 2 pi. And so in order for us to solve for theta, so we have this equation here, r equals 3 cosine 2 theta, if r is equal to 2. So all they want us to do is take that value for r and replace it into the equation. So we're just going to take the fact that r is equal to 2 and substitute that in for 2. Okay. All right. So there's my lights. Man. Okay. So I will have 2 is equal to 3 cosine of 2 theta. So we are always going to substitute there first. And then once we do our substitution, then we're going to isolate. So we're going to substitute. So let me put some steps off to the side here. So you want to substitute, right, your r value. And then you're going to isolate your trig function. I'm just going to write it as trig theta. So in order to do that, we're going to divide both sides by 3. And then I'm going to flip the equation around. So I would have cosine of 2 theta is equal to 2/3. And then once we do that, we're going to isolate our theta term. And we do that by doing like your inverse, right? So now from here on, this is going to look like questions 1, 2, and 3 that we just finished. So I'm going to take the cosine inverse of both sides. And then I'm going to do that in my calculator, right? So that will be our calculator step. So I'm going to do cosine inverse of 2/3. And then when I do that, I get 0.841, okay? And then once we do that, then we want to find all of our angles. So once we isolate our theta, and I should say term because in this case it's 2 theta that we're actually isolating, right? And then we want to look for all of our angle values at this point, right? And then find all angle values. So meaning you might have to look in other quadrants, right? So that's what that means there. Or even a little extra, as you're going to see here in just a minute, okay? All right, so I know that cosine, so I'm going to do that off to the side here. So I know cosine is positive for where x is positive, which is to the right. So that means I have those two values there, right? So the one that I just found was quadrant 1, right? So that was the 0.841. And so I still need to find my rotated angle from 0 into quadrant 4. So to find my quadrant 4, I did not make it to 2 pi, right? So I stopped before I got to 2 pi. So that means it's going to be smaller than 2 pi. So I have to subtract that 0.841. So I'm going to go ahead and do that. So 2 pi minus 0.841. And then that would give me 5.442. Okay. All right, and then in the previous chapter, as a little reminder, because we have a 2 theta, that means it goes around the circle twice. So if I have that 2 theta, I'm going around the circle actually twice. So I need to make sure that I'm adding 2 pi to each of those answers, right? So I have to add 2 pi to that one, and then also that 5.442. If this was a 3 theta, I would have to add 2 pi just like I'm getting ready to do, and then I would have to do it again, right? Because I would go around 3 times. So then that means I'm actually going to have not 2 answers, but I'm going to have 4 answers, okay? So I'm going to just do that on the line below. So I have 2 theta, so I have my original 0.841 and 5.442, and then now I'm going to add 2 pi, right? Add 2 pi to that. And then I get 7.124, and then now I'm going to take the second value, the quadrant 3 or 4 value, 5.442, and I'm going to add 2 pi to that as well. And when I do, I get 11.725. Okay. And so I have 4 answers, 2 per rotation. And then finally, the last thing I need to do is I need to still solve for theta. So I'm not quite all the way done. So I need to divide everything by 2. So I'm going to go ahead and do that. So divide both sides by 2. And then that will give me my final answers. So this first one, so these should be all wiggles here. So my first one would be 0.420. And then 2.721, 3.562, and I'm going to run out of room here. And then finally, I'll just put it here, 5.862. And so that would give me my 4 answers. Okay? All right, so if you feel pretty good about number 4, then go ahead and press pause and try number 5. Okay, so for question number 5, so we're going to follow those steps again. So the first thing we want to do is substitute in our r value. So this r is equal to 3. We're going to substitute that and replace it. And then we're going to isolate. So in order to isolate, I'm going to subtract 2 from both sides. So 3 minus 2, and then that will give me 0, of course. And then divide both sides by -5. So I would have -1/5 is equal to cosine theta. But let me actually flip that around. There we go. Okay, and so if you didn't press pause now and try at least the second part. Okay. All right, so then I'm going to take the cosine inverse of both sides. And then I know for here, so cosine is negative in these two quadrants, right, where x is negative, so that would be in quadrant 2, and then again in quadrant 3, so that's where cosine is negative. So then I'm going to type that into my calculator. And then I got 1.772. And so then now that gives me this value here from 0, right? So that value from 0 is 1.772. And then because of symmetry, that means this is also 1.772, and then of course that's pi. And then let me mark the 2 pi. So for me to find my quadrant 3 answer, what I have to look at is a full rotation is 2 pi, right? So a full rotation, if I were to go all the way around, is 2 pi, but I'm not going all the way around, right? So I'm only doing part of the way around. And so I know the section I didn't cover was this section right here. And I know that section is 1.772. And so if I went all the way around, that's 2 pi, but I didn't. I stopped before 2 pi by that amount. So that means I need to do 2 pi minus 1.772, and then that will find me my quadrant 3 answer. And that would give me 4.511. And so there's those two values there. Okay? All right, so if you're good with 1 through 5, then again, you should be good for the rest, because all we're going to be doing from here on out is just more solving, lots of solving, but we're going to throw in that element of graphing as well, which is a really good review off of the last objective. So objective 3A and 3B will both be incorporated in here. So you may also want to press pause for a quick minute and get out your objective 3 notes or go back and review those really quick, just so that you have a pretty good handle on the graphing piece of it. So the solving we just covered, but the graphing, of course, was a couple of days ago. Okay? All right, so let's go ahead and take a look at the first question, which is to graph. So for this one right here, they want us to sketch both equations on the same graph and then find where they intersect. So they're asking specifically, though, for the points of intersection, right? So the points of intersection. So we need to make sure that when we do the points of intersection, that we are giving both a value of r and a value of theta, right? So we need to make sure that we're giving both of those there. All right, so let me go ahead and set up my graph paper, so to speak. So I'm just going to do that off to the side here. Okay, so I'm going to use 2 different colors here to graph. So I have r is equal to 3, so I'm going to use red for that one. So r equals 3 just means a radius of 3. So that means I'm going to go out a radius of 3 on each of my quadrantals, and then connect those to make that circle that has a radius of 3. Okay, so that would be that first graph. And then for this one right here, so r is equal to 2 secant theta. So that one is going to be a line. So if you kind of remember like a little bit of shortcuts and such like that, like you can think of, okay, secant's a reciprocal of cosine. Cosine is my x values. So this would just be the same as x is equal to 2, right? X equals 2. So I go on the x-axis where that is 2, and then I draw in a line that passes through that x-axis, which is a vertical line. Okay. All right, or if that's like, what just happened there? So then what I would do is I know, again, cosine theta is x over r. So then secant theta is r over x. So then if I take that and substitute that in, I would have r equals 2, and then secant, of course, is r over x. And then I would solve that equation. So I would solve it by multiplying both sides by x, and then dividing both sides by r, and I would get that same equation I was just talking about, which is x equals 2. Okay? All right, so there is the graph, and we are looking for 2 points of intersection, possibly though. So this might get a little tricky, so keep that in mind. So we're looking for 2 points, or 2 possible points of intersection, and we will talk about what do I mean by that, because you're going to see this multiple times in the note, so hopefully it will make sense, because I know it doesn't always the first time around. So if it doesn't make sense to you, do make sure that you watch some of those videos to kind of help you out with that. Okay? All right, so now ready for the solving. So I'm going to do the solving over here. Okay, so for solving, when we're looking for points of intersection, we know 2 graphs are going to intersect when they are equal to each other. So all I'm going to do is I'm going to take these 2 equations here, and then I'm going to set them equal to each other. So I have 2 secant theta is equal to 3. Okay, so these are both equal to r, and so make them equal to each other, and then we're just going to solve this equation. So to solve it, I'm going to isolate the trig function, right? Always, that's what we want to start with. So divide both sides by 2. And so we could take the secant inverse of both sides, but most of us don't have calculators that have a secant button. So we're going to do a reciprocals instead. So the reciprocal of secant theta is cosine. So if I take the reciprocal of the left side, I have to take the reciprocal of the right side. So instead of 3/2, that will just be 2/3. And then now it's solving just like we did in 1 through 5, right? So that just keeps coming back to haunt us, okay? So I'm going to take the cosine inverse of both sides. So you're going to get really good at solving by the end of this chapter here. All right, so then I'm just going to do that in my calculator. So I do the cosine inverse of 2/3. And I get 0.841. Okay, and so just off to the side over here. So cosine is positive in quadrant 1 and 4 because it's an x value. So I know this distance here is 0.841, and I am left to find my quadrant 4 answer, so I have to rotate from 0 into quadrant 4. And so this gap right here has to be the same distance, right? Because of symmetry, that reference angle is the same. And I know this is 2 pi. So I did not make it all the way to 2 pi, right? So I stopped before I got into 2 pi radians. And I stopped short by that same amount. So because I'm before it, I stopped short of it, I want to subtract, right? And that will give me my quadrant 4 answer. So then again, we're just doing that in our calculators, we're not doing that in our heads. So 2 pi minus 0.841. And then I got 5.442. Okay. So normally, like in the questions 1 through 5, we'd box it, we'd be like, yay, we're done. But just a reminder, the directions asked specifically for the points. And so we just solved for theta, so we need to figure out, well, what the heck is r? But luckily for us on this one, we don't have to solve for it. They just told us r is 3, right? So r is 3, and all we just looked for was theta. So that makes it really simple for us. And so then our actual answer are the ordered pairs, right? Those points is what we're searching for. So remember, r was 3, and then we have 2 theta values, so we have 2 points of intersection, which makes kind of sense here, right? Because if I visually look, I say, oh yeah, there's 2 there. So 0.841. And then one more here, and the other one again, r is 3, and then that angle we found was 5.442. Okay. All right, so let's take a look at one more in this kind of category, number 7. So again, for here, you should probably press pause, give it a whirl, and see what you came up with. Okay. All right, so let me go ahead and graph that off to the side here. Okay, so again, I'm using 2 colors again. So I have For this one here, I'm going to use red. So negative 4 cosine theta. So I know it's not like in the cardioid or limosome realm, so it's got to be in kind of that pedal realm. And so this would be b is equal to 1, so which is an odd number, so there would be like one pedal. But instead of one petal, like that teardrop shape, it really is a circle, right? Whenever we have one petal, it really is a circle. So I'm going to be graphing a circle, and it's going to go through the pole where cosine is negative, which is to the left. So cosine is negative to the left. So I'm going to go out 4 units. And then I'm going to create that circle that has a diameter of 4. Okay. All right, and then theta equals 3 pi over 4, so this one right here. So 3 pi over 4 I know is in quadrant 2 because this is pi, or 4 pi over 4. So somewhere right around there, right? So not perfect, but there we go. Okay. So when I look at this graph, it looks like I am going to be searching for 2 points, right? It looks like there's 2 points of intersection, right? Like when I visually look, it looks like they're hitting each other in 2 different spots. Okay? All right, so let's go ahead and solve that equation. So for this particular one, when I take a look at it, this is not r, right? It doesn't say r is equal to da-da-da. It says theta is equal to that. So this time, so a little different, I have to take that theta value and I want to replace it with 3 pi over 4. So in this particular time, I'm going to do negative 4, and then I'm going to do cosine instead of theta. I'm going to do 3 pi over 4, right? And so in this case, it makes it so easy to solve for, right? So then I just need to figure out, well, what is that value? And so I know that cosine of pi over 4 is root 2 over 2, but we are in quadrant 2, so then that's going to be negative root 2 over 2. And then when I simplify that, that double negative will go positive, and then 2 goes into 4 twice, so then r would be equal to 2 root 2. And so then I would have an ordered pair, right? So for points, remember, our final answer should be r and theta, r and theta. So we just solved for r. R was 2 root 2, so this time we solve for r. Oops, I don't know why I have a comma there. And then, of course, I switched to pen, so let me wipe that out real quick. There we go. So r was 2 root 2. And then now I don't have to solve for theta because theta was given to us. Theta was given as 3 pi over 4. And so that would be my answer. So it looks like there's 2 like intersections, right? It looks like there would be 2 intersections here. And so I know that for this ordered pair here, the radius is 0 when theta is 0. So however, but if I look up here, if theta were 0, so let me just kind of do that off to the side right here. So why is there not 2 intersections? That's what we're talking about. So why is this one not popping up as a solution? So I know that for theta equals 3 pi over 4, so for this one right here, that would be, the only time that would be true is if the radius was 0, right? So if the radius was 0, but the angle is still 3 pi over 4. Up here, however, in order for me to be at the radius of 0, that would be actually at pi over 2, right? So if I were to look at this guy right here, when will the radius be 0? So divide by negative 4, so that's still 0. And then I know that cosine is 0 at pi over 2. So for this graph, I get a radius of 0 when the angle is pi over 2. But for this one, I get a radius of 0 when the angle is 3 pi over 4. So even though visually we're like, oh, well, isn't that a point of intersection? It isn't for polar. And this is kind of very confusing for students to understand, is that what is happening is, yes, the radius is 0 for the two equations, but it takes different angles to make that radius of 0, so then they are not a true point of intersection, right? Not a true point of intersection. There is only one on this particular problem, okay? And I know that can be kind of confusing, but we have, I think, like 2 or 3 more problems that happens to again, okay? All right, so let's go ahead and move on to the last page. Okay, so this is kind of in that same realm as just different graphing that we have. So for here, we are sketching each system on the same graph, so just like before, and then we're solving each system of equations. And so very much the same here. So they, in the previous one, they asked for the points of intersection, which is also equivalent to saying solve the system of equations, okay? All right, so let's go ahead and we're going to graph number 8. So let me go ahead and do that over here. So I need to go make sure I have enough room because I see that I'm working with 6s there. So I think it'll, okay. Okay, so I'm going to do the same thing again. I'm going to use 2 different colors here to graph this. So I'm going to start with this one right here. So I know that I'm working with a limacon or a cardioid, and I know that 2 is less than 4. So a limacon with a loop because of the less than, right? Limacon with a loop. So then I know it's also a positive sign. So sign is positive up here. So the orientation is going to be that way, right? My shoulders, so these guys right here, so on the horizontal, are going to be at A, so that would be out 2 units left and right. And again, I can plot points, right? I can always plot points to figure out how to graph. And then I'm going to subtract those 2 values, so 4 minus 2, so that gives me 2, so that is my inner loop. So, and I'll pass through the pole. And then 2 plus 4 is 6, so then that's the diameter of my outer loop. So then I'm going to try to make this as round as I can. Whoops, that got a little asymmetrical. Okay, there we go. Sorry, there was a little glitch there. Hopefully it's still going to be recording. Okay, so then now for my other graph, so let's go ahead and take a look at that one there. So r equals 6 sine theta, so definitely not in that cardioid limacon family because there's no addition or subtraction. So then that means it's got to be in kind of that petal family, right? And so b is equal to 1. So that would be an odd number, so like 1 petal, but we don't make a teardrop, right? We make that circle, and that circle will have a diameter of 6. And then it's a positive sign, so it's going to go up. And so it's going to go through the pole and then right there as well, right? And then we're going to have a circle, which that's not very good. But then we would have some sort of circle there. And so again, when we are solving systems, we are looking for intersection points, right? So that's just like the previous problem that we had. Okay, so for our intersections, so we're going to do the same thing as what we have been doing. So we're going to set, in this case, these are both r equals, so we're going to set the 2 equations equal to each other. So we have 2 plus 4 sine theta, and then that's equal to 6 sine theta. And then we just want to solve that equation just like we have been doing, right? So this is exactly like the previous problem. So we're going to subtract 4 sine theta. And then divide both sides by 2. And then I'm going to flip the equation around, so I would have sine theta is equal to 1. And so then take the sine inverse of both sides, and then I know that sine is equal to 1 at pi over 2. Right? And that's it, right? That's the only place that it's equal to pi over 2. I just realized the directions probably should have said between 0 and 2 pi. And so it doesn't, but that's what we're going to go with. So theta is equal to pi over 2. So the nice thing is they don't ask for the ordered pair. And so we just have to find our theta value. So theta is equal to pi over 2. And so that brings up an interesting point, because if I look here, right, if I look at the graph, so again, it looks like we have 2 points of intersection we should be searching for, but the only one we found was this one up here. So it's like, well, where is this one at? You know, what is happening with this point of intersection? Like, why is that not included? And so this, again, this is not a true intersection, because when r is equal to 0, that is happening at different theta values for these two equations, right? So this bottom one is not a true intersection. And that is not a true intersection because it requires different values of theta for each of those equations, right? To have r equals 0. So if I were to take r and replace it with 0, I would not get the same angle, right? And so because of that, that means they're not touching and hitting that point at the same time or at the same moment. And so then we would say they're not a solution to the system or a point of intersection. So it's kind of a look at parametric equations. It kind of gives you an idea for that. Okay? All right, so sometimes it can be very confusing, but that would be our values there. Okay, so let's take a look at number 9. So again, you should pause number 9, or pause here, try number 9, and see what you get. Okay? All right, so let me set up my graph paper here. Okay, so to graph r equals 6 cosine 2 theta, so I know this is a petal graph, right? So this is going to be the graph for the petal. So let me go ahead and I'm going to do the work off over here as well. So the first thing I'm going to do is find the first petal, right? So to find my first petal, I set my equation 6 cosine 2 theta equal to the length of the petal, which is 6, right? So when r is 6. And then divide both sides by 6. And then I know that cosine is equal to 1 at 0. And then divide by 2. So 0 divided by 2 is 0. And so then for that one, then I know theta equals 0 is where my first petal is. And then I'm going to make that teardrop shape. And then for my spacing, I have b is equal to 2, which is even. So that means there's going to be 4 petals, right? Twice as many petals. And so I divide that into 2 pi. So that would be pi over 2. So that means there's going to be a petal at every quadrantal. Okay. So then I'm going to go up 6 and draw in that teardrop. The next pi over 2, which is the next quadrantal, and then pi over 2 again for the next quadrantal. And there we go. Okay, so that's r equals 6 cosine 2 theta. And then now for my other graph, so I have r equals -3. So that is just saying that you have a radius of -3, which seems kind of confusing, but if you think about it, so if I go to theta equals 0, I want r to be -3, so that would be over this way, right? So I'd go away from 0. And then at pi over 2, r is -3, so away from it. And then if I go over to pi, r is -3, so away from it. And then at 3 pi over 2, r is negative 3. So instead of going towards 3 pi over 2, I go away from it. So I still get those 4 dots. It just they occur at different times, right? And so then when I look here, I'm going to get that picture there. Okay. So if I look at this, it looks like I should have 8 intersections, right? So 2 per petal, right? Isn't that what it looks like? But so far, that's not been proven very well, right? We've had a couple instances where it looks like we should have this many, and then we find half as many, which is great because that's just half the amount of work. Okay, so let's go ahead and solve it, and I'm gonna. So let me well, here, let me start this way. So the first thing I'm going to do is, so these are both r equals, right? So I'm going to just set these two equations equal to each other, and then I'm going to do that down below here. So I'm going to write it, and then I'll scoot it up here in just a quick second. So I would have 6 cosine of 2 theta, and then that's equal to negative 3. So then let me slide that up. All right, so that's the equation I'm going to be solving for. So the first thing I want to do is divide both sides by 6 to isolate the function. Okay, and then once I do that, I'm going to take the cosine inverse of both sides and look for where cosine is negative. So this is a value on my unit circle, so I'm going to go ahead and just do that based upon my knowledge of unit circle. So I have cosine is negative to the left because it's our x value, so that would be in quadrant 2 and 3, and so this is pi. And so then my reference angle, so kind of that theta prime value, so where is cosine equal to 1/2? And that would be at 60 degrees or pi over 3, right? So pi over 3. And so then so I should write this as 2. So then that means that 2 theta, right? Oops, I know I'm going to need a little extra room there. So then 2 theta is going to be, so get a common denominator here. So from 0, I stop before I get to 3 pi over 3, so that would be 2 pi over 3. And then I go after 3 pi over 3, so 1 after that, so that would be 4 pi over 3. And so then I know that I have that 2 theta, right? So whenever I have that 2 theta, it means I need to add 2 pi to each of my angles, right? And then when I do that, that's just finding that second rotation, right? And if I had a 3 theta there, I'd have to add 2 pi a couple of times, so then it would be a lot of work. So I want to go ahead and get that common denominator. So I know 2 pi is the same as 6 pi over 3. And that's just to make it easier for me to add it to these, right? So this is just 2 pi. So when I add these two together, I'm going to add my numerators. So that would be 8 pi and then over 3. And then I'm going to add these two together. So that would be add my numerators. So 10 pi over 3. So just about finished. So then I need to finish solving for theta. And I'm going to do that by dividing both sides by 2 or multiplying by 1/2, right? So I'm going to multiply, oops, I wrote a third. How about 1/2? So I'm going to multiply that by 1/2 and that by 1/2. So over here, so that would just reduce down to 1 theta or theta. And then when I multiply these together, the 2's will cancel, leaving just pi over 3. And then over here, 4 and 2 will reduce, so that leaves 2 pi over 3. And then here, 8 and 2 will also reduce, so that will give me 4 pi over 3. And then finally, 10 will reduce with 2 as well. And so that will leave me with 5 pi over 3. And so there are 4 answers, which is contrary, right? Contrary to where what visually is happening, right? So if I take a look at, so let me zoom out just a little bit so I can kind of point and look at both of these here at the same time. Okay, so if I look, it looks like I have, 8 points of intersection, right? But the only ones that are popping up are those 60-degree marks or those pi over 3 marks. So the only ones that are really showing up is these guys right here, right, at those 60-degree marks. So why are we not having those other 2 intersections? Like, why is that not happening? And again, it's that same concept that it requires different values of theta to get that same r or different values of r with that theta, that they're not landing at those points at the same time, so they're really not an intersection point. They both kind of pass through that same moment, but just at different times, right? So they will, the red graph will hit here, but it takes a different time period for the blue graph to hit that same point. So they're really not points of intersection because they don't have the same r as the same theta. And really what's happening here is this intersection occurs when the radius is actually equal to 3. So when the radius is 3, positive 3, then that's when they will be intersecting together over here and here. Okay? All right. I know that can be confusing, but there are only 4 intersections where they have the same r value and the same theta value at the same given time. Okay? All right. So just trust your math. Trust the math, not the eyeballs, I guess. That's my piece of advice. So trust your math and not your eyeballs. Okay. All right. And then let's go ahead and take a look at the last one here, number 10. So for question number 10, so we're going to do the same thing again. So we're going to go ahead and do our graph first. Okay, so I know that I have kind of that cardioid lemmasone family because I have that adding or subtracting. And I know that it's a positive cosine, and cosine is positive to the right, so that means it's going to head to the right. And then because these are equal to each other, when I subtract, I would get 0, so that means we're going to have no inner loop, and so that means we're going to have a cardioid. And so then when I graph this, so my shoulders, these guys right here on the vertical, are going to be at 1. So I'm going to go up and down 1. And then I'm going to add those two numbers together to get that distance of that outer loop. So 1 plus 1 is 2. And then 1 minus 1 is 0, so no inner loop. And so we get kind of this little cardioid guy right here. Okay. All right, and then for this one right here, so r equals 4 cosine theta. So it won't be in the cardioid lemmasone family because there's no adding or subtracting. And so I know that it's kind of in that petal family. So b is equal to 1, which is odd. So there would be 1 petal, but not like that teardrop petal. A single petal is actually a circle with a diameter of 4, right? So diameter of 4. And it's a positive cosine graph, so just like this one headed to the right, so will this one. So I'm going to go 4 units to the right. And then draw in my circle. Okay. So when I look at this one, it looks like I could have 3 intersections, right? 3 intersections is what it looks like at the pole, and then 2 other times. So, but hopefully we have figured out that what we see is not always what we get. And that will be true for this one again as well. Okay, so it looks like there's 3 intersections, but fingers crossed. So let me show my cross fingers. So fingers crossed that we actually won't get 3, because that means that we don't have to solve for all 3. Okay, so then I am going to start by equaling these to each other. So I'm going to start doing a pen again. So I would have 1 plus cosine of theta, and then equal that to 4 cosine theta. And then isolate our trig function, so I'm going to subtract cosine theta from both sides. And then divide both sides by 3. And then that is not a quadrantal, right? So that is not a quadrantal, so then I'm going to have to use decimal values in my calculator again. So I'm going to take the cosine inverse of both sides. And then type that into my calculator. And then let me go ahead and set up over here though first. So I know I'm going to do where cosine is positive, which is to the right, because it's the x value. So I should have a quadrant 1 and a quadrant 4 answer. So let me type this in first. And so when I do that, I get 1.2309. So that is this one here. Okay, and so I'm left to find for quadrant 4, right? So quadrant 4, the rotated angle has to start from 0 and go to here, right? So I know this gap right here has to be the same as this gap up here, right? That angle has to be the same. And then I know a full rotation of a circle is 2 pi, right? So if I were to go all the way around the circle, that would be 2 pi units. But I didn't make it all the way around, did I? I stopped before I got to 2 pi. So before I got to 2 pi, so that means I have to subtract, right? So it's a little bit smaller. And then I'm going to subtract that decimal. And again, I'm not doing that in my head. I'm going to be using my calculator for that. So I'm going to do 2 pi minus 1.2309. And then when I do that, I'm going to get 5.052. And so here I got 2 points of intersection, so these two guys right here. So the pole here is not a point of intersection because that just means it requires a different theta to get that R value of 0. So although they both pass through the pole, they don't do it at the same time. Okay? And that's it for this lesson.